Who's starting?
Okay. Should I go?
It doesn't matter. Yeah, I'm ready when you are.
Okay. So we are looking at determination of trace metal content in papers for forensic applications using optical emission spectroscopy. So what we're doing is we're taking samples of paper and we're cutting them up into little corners. So the top corners, the bottom corners, and the middle of the paper. And what we're doing essentially is digesting that paper into a completely aqueous sample with nitric acid and hydrogen peroxide to run through the ICP. So the ICP is inductively coupled plasma, and ours is an optical emission spectrometer. So this aqueous sample runs up through here and hits this nebulizer, which turns it into a very fine mist, where it hits the plasma and then goes over into the spectrometer. And what it does is it measures 13 different metals. And from there we analyze 5 metals in particular that come out positive.
So basically, in order to do that, we run standards through first, and then I make a calibration curve on Excel using all of the data from that, and then I end up with an equation and some R-squared values, which come out pretty high. And then I use that entire equation using the emission that we get from the spectrometer, run it back through the equation, and that's how I get all of these numbers right here that tell us the weight percent of the metal concentrations in the paper. So looking at the 2 different kinds that we ran so far, we have the loose leaf and the printer paper, and there are some substantial differences between the magnesium tube spike on the printer paper than the loose leaf. And we have come to find out that the ink that they use on the loose leaf paper has no play in anything that we've done. It is all organic. So it does absolutely nothing, so it's great for us.
Right.
And then barium actually came out positive in the printer paper where it had a value of 0 and the loose leaf. So our research is doing pretty well. We would like to continue doing more, and so we just need to be able to digest that down. I only have 1 set of printer paper ran, so I do need to run a couple more times for that just to validate the numbers and then continue on from there.
So we're doing this research for forensic applications, so in the case of counterfeit money, ransom notes, so when we get a piece of evidence in, we can potentially trace that piece of paper back to the suspect's home or paper in the home itself. So right now it's looking promising that between loose leaf and printer paper, I can see that the aluminum, barium, and magnesium all have different values, so that's a good step.
So it's just another way to validate what they already know, because for forensics right now, anything that has to do with ransom notes, they know how to compare ink samples, nothing that has to do with the paper. So we're looking at just another way to validate, yes, this is the suspect.
Cool.